Lumen point. Let's begin the breakdown.
All right, let's get into it. You probably think you know black holes, these giant cosmic vacuum cleaners that warp reality itself. But what if there's something else out there? Something that looks like a black hole, acts like a black hole, but is something else entirely. Today, we're talking about a theoretical object called the Gravastar.
I mean, talk about a bold statement, right? That really sets the stage for what we're about to explore. A hypothetical object so wild it could completely change how we think about the most extreme physics in the universe.
So to even understand this potential twin, we have to go back to the beginning, or more accurately, the end. The incredibly violent, explosive end of a really, really big star.
So picture this, a star, way bigger than our sun, finally runs out of fuel. Its core collapses in on itself in less than a second. The rest of the star comes crashing down, bounces off that core, and triggers a supernova, an explosion so powerful it can outshine an entire galaxy for a little while.
Okay, so once all that cosmic dust settles, science says one of two things can be left behind. Either the core gets crushed into an unbelievably dense neutron star, or if the original star was truly massive, it just keeps collapsing forever. It collapses into a singularity, a point of infinite density where our laws of physics just break. And that's what creates a black hole.
And here is where our story takes a wild turn. What if physics doesn't break? What if, at the very last possible nanosecond, something else happens instead? This is the wild idea that gives birth to the Gravastar.
So how do you actually build one of these things? We're not just talking about a star collapsing anymore. This is more like a cosmic construction project, happening under conditions that are almost impossible to imagine.
Okay, so follow this. Instead of collapsing to a single point, the core gets so compressed it basically turns into pure energy. This creates a bubble that pushes outward violently. At the exact same time, the rest of the star is still collapsing inward, so you have these two incredible forces smashing into each other. It's like some cosmic blacksmith hammering on an anvil, trapping all that star stuff in between and forging it into something brand new. And then, it just holds. That's a Gravastar.
So what is this thing we've just made? What does this cosmic bubble, forged in the heart of a dying star, actually look like on the inside? Well, its anatomy is somehow even weirder than its birth.
Let's just try to get a sense of scale here. We are talking about an object that's roughly the size of a big city, but it has the mass of 10 of our suns packed into that space. The density is it's almost impossible to comprehend.
And get this, the temperature. The shell of a Gravastar is thought to be the coldest theoretical object in the entire universe. It's just a billionth of a degree above absolute zero. That's as cold can possibly get. It's so cold, the background radiation of space would seem like a blazing furnace next to it.
So you basically have two parts. You've got this impossibly thin, incredibly strong shell made of some kind of exotic matter we don't even have a name for yet, and inside, it's a perfect vacuum, totally empty. Or is it? Okay, to understand the core, we have to talk about something called vacuum energy. Now stay with me. The best way to think about it is that the universe is filled with this invisible cosmic ocean. The particles that make up you and me and everything else are like waves on that ocean. But even when there are no waves, the ocean itself is still there, and it has energy.
Now the core of the Gravastar is what happens when you take that cosmic ocean and compress it as far as physics will allow. So it isn't empty at all. It's a vacuum that's been pushed to such an extreme state that it is just seething with a ridiculous amount of energy.
And all of this creates the ultimate cosmic standoff. You've got this super energetic core pushing out with incredible force, and this impossibly strong shell pushing back, holding it all in. It is a perfect, eternal stalemate between two of the universe's absolute limits, and that's what makes a Gravastar stable.
This is all just unbelievably cool theory, but how could we ever actually prove it? I mean, how do you listen for something that, from the outside, seems exactly like its more famous twin?
And yeah, that's the big problem. Because they're so massive and so compact, Gravastars would bend space-time in the exact same way as a black hole. They'd have swirling disks of matter, they'd warp light, everything. If you were looking at one from a spaceship, you wouldn't be able to tell the difference. Which, leads to the obvious question. If you can't tell them apart, why bother? Why come up with this whole new, complicated idea instead of just sticking with the black holes we already know?
Well, because black holes give physicists massive headaches. They seem to need singularities, where all our laws of physics just stop working. And they also seem to destroy information, which, according to the rules of the universe, should be impossible. Gravastars fix both of those problems beautifully. No broken physics, no lost information.
Of course, there's no free lunch in physics. In solving those paradoxes, Gravastars create their own puzzles. You have to be willing to believe in this totally new kind of exotic matter for the shell, and this idea of a superdense vacuum. It's really just trading one set of weird problems for another.
But there is one potential clue. One way we might just be able to settle the debate. We just have to listen really, really closely to the sound they make when two of them collide.
And this is the key difference. When two black holes merge, their event horizons just sort of meld together. The gravitational wave signal is like a sharp, deep thump, and then it's over almost instantly. But if two gravastars merge, their physical shells would actually crash into each other. The signal wouldn't be a thump, it would be a gong, a cosmic bell that rings and resonates, leaving these tiny, faint echoes vibrating through space-time.
The problem, of course, is that detecting those echoes is incredibly hard. The gravity around these things is so powerful it just swamps most of that signal. It's like trying to hear the difference between two kinds of bells ringing behind a thick concrete wall. Our technology just isn't quite sensitive enough. Yet.
And, that really gets to the heart of it all. The search for things like gravastars isn't just about finding some new weird object. It's about pushing at the very edges of what we know. This is the whole point of science, to keep looking and to be ready to learn that reality is even stranger and more wonderful than we ever imagined.
So, as our gravitational wave detectors get more and more sensitive, you have to wonder, are we about to hear something new in the music of the cosmos? A faint echo from a cosmic gong telling us that black holes aren't alone out there in the dark? Only time and a whole lot of very careful listening will tell.
Fuel your curiosity. Subscribe for the explanation. Stay for the knowledge.